He'd not wanted to be an ambulance driver especially. In the first place, the world was full of ignorant people who pronounced the word ambulance. In the second place, he'd wanted to be a baseball player. He'd almost been one too. All the way back to his freshman year in high school, he'd been billed as a premier pitcher destined for the major leagues. And even though he'd only weighed 145, he could reach back out of sight, as the old men put it, and fire with a deadly accuracy rising at the mitt that popped with delight at never being able to fool him. He could put it anywhere, too. Didn't need the junk the way other pitchers did. That was because he'd already seen the batters in his sleep the night before, stared into their sweaty faces, and disgustedly witnessed the way they twisted themselves into torturous poses, trying to connect with the round blur that was, for most of them, as elusive as Eschel's dream. He'd been more than good. Once, Joe Engel, coach of the minor league franchise out of Chattanooga, had driven 30 miles to watch him pitch. The man had wanted to sign him, but not before he graduated from high school. He'd been good, no doubt about it. Too good for that hayseed coach, McEwell. McEwell had been jealous of Eschel's prospects for the big time and had started trying to tell Eschel what to do. McEwell knew that Eschel couldn't sign in the pros until he got out of high school. So McEwell was trying to make a name for himself, which was fine, until McEwell began dictating Eschel's pitches to him. It came to a head one game when, in the fourth inning, Eschel had thrown 2 strikes, both curveballs breaking on the outside corner, to a batter who'd practically fractured his wrist trying to get to them. One more pitch and Eschel would retire his side, 3 up and 3 down, on his way to a third consecutive no-hitter. But McEwell had drawn the catcher's attention to the dugout, flicking his wrist downward as a sign that Eschel was to throw a fastball. If one was inclined to play the odds, it wasn't bad strategy. But Eschel had never been one for the odds. Besides, he wanted to see this batter, a boy with chubby arms and ill-fitting pants, make a fool of himself for daring even to step into the box. Eschel might even do the unexpected and throw the high, inside fastball. But no, the catcher had called for a fastball waist-high and down the middle. Eschel cut his eyes over the dugout where McEwell stood cross-armed. Eschel faced the catcher once more and shook off the pitch. As before, the catcher, Eschel's first cousin and a boy named Wallace, called for a fastball. Eschel screwed up his face threateningly and let the word no signal caution from his lips. Still, the catcher showed a single finger pointing toward the dirt. Eschel ignored this last appeal, kicked his leg toward the sky, and let the ball roll off the ends of his fingers, but not before giving his wrist a sharp twist that sent the now airborne projectile spinning in the opposite direction from the one the catcher intended. Eschel had struck out the batter, but knocked the catcher out in the process. The coach had suspended his star pitcher for 2 weeks. Eschel had first been seen as a major league pitching prospect. This is a specific detail question. Let's go back to the passage and find the place where we can locate the answer. Look at the sentence, all the way back to his freshman year in high school, he'd been billed as a premier pitcher destined for the major leagues. Now let's look at the question and the options, and we can see that option B matches the text as a freshman in high school. I would go with answer B. The catcher was what relation to Eschel? Toward the end of the passage, we find this line. As before, the catcher, Eschel's first cousin, and a boy named Wallace. Now let's go back to the question, and we can see that the answer here is first cousin. Answer H. From the passage, we can assume that McEwell began dictating pitches to Eschel because, looking at the passage, let's find the sentence where McEwell began dictating pitches. Here it is. So McEwell was trying to make a name for himself, which was fine until McEwell began dictating Eschel's pitches. Now, why was he doing that? To find the answer, we need to look a couple sentences before that. McEwell had been jealous of Eschel's prospects for the big time and had started trying to tell Eschel what to do. Let's go back to the question. Looking at the options, option D is our best choice. McEwell was jealous of Eschel's major league prospects. Answer D. Escholds High School was approximately how far from Chattanooga? This is another specific detail question. Let's find the appropriate sentence where we can get the answer. Looking at once Joe Engel, coach of the minor league franchise out of Chattanooga, had driven 30 miles to watch him pitch. So we can assume his high school was 30 miles from Chattanooga. Looking at the question again, it seems like it's option H, 30 miles. McEwell signaled to the catcher that on the next pitch, Escholds was to throw. We need to look for the answer for this in two places. In the sentence, but McEwell had drawn the catcher's attention to the dugout, flicking his wrist downward as a sign that Escholds was to throw a fastball. We know he called for a fastball. But what kind of fastball? Well, in this sentence, but no, the catcher had called for a fastball waist high and down the middle. Now we have our complete answer. Looking back to the question, don't be trapped into saying answer D, a fastball high on inside. We want answer B, a fastball down the middle. The answer to this question is answer B. The passage implies that Escholds' attitude toward the opposing batters was primarily one of. This is an inference question. I believe we have plenty of evidence in this passage to rule out options F and G. We know Escholds wasn't sympathetic or didn't have much friendship with the opposing batters. But is it H or J? Is it hatred or ridicule? I would look at this sentence. Besides, he'd wanted to see this batter, a boy of chubby arms and ill-fitting pants, make a fool of himself for daring even to step into the box. I believe from this sentence I could infer that Escholds' attitude was more ridicule than it was hatred. I would go with option J. The passage suggests that, for a pitcher, Escholds' weight was. Let's find the sentence that mentions Escholds' weight. And even though he'd only weighed 145, from this sentence we can infer, I believe, that his weight was a little below average. Let's look at the question. I would pick option A here, below average. The phrase, never being able to fool him, refers to let's find the appropriate sentence. He could reach back out of sight, as the old man put it, and fire with a deadly accuracy rising into mitt that popped with delight at never being able to fool him. Well, what couldn't fool him? It seems that the mitt couldn't fool him, which indicates that his pitching accuracy, as the passage said, was deadly. Looking at our options, I would go with answer F here, that never being able to fool him refers to Escholds' pitching accuracy. Answer F. It can be inferred from the passage that, as a baseball player, Escholds Let's look at these sentences. In the second place, he'd wanted to be a baseball player. He'd almost been one, too. Now let's look at the options. I would rule out option A. I'd also rule out option C. We have no evidence that he continued pitching part-time. Option D is also out. The passage indicates that Escholds had a lot of talent. This leaves us only with option B, that Escholds had stopped for some reason beyond his control. Answer B. As elusive as Escholds' dream refers to. Let's look at this sentence. They twisted themselves into tortuous poses, trying to connect with a round blur that was, for most of them, as elusive as Escholds' dream. Well, what was elusive? From the sentence, we can see that the round blur was elusive. Let's look at the options. This round blur does not refer to the batters, to his prospects, or to his coach. In this case, I would go with option J, a pitch Escholds threw. That was the round blur. Answer J. The associative stream studied in the psychology laboratory comes nowhere near the complexity of the associative stream each of us experiences in our private lives. For this reason, it is necessary to step outside the laboratory and look directly at an everyday phenomenon, daydreaming. Perhaps the most famous bit of literary daydreaming was done by Molly Bloom in James Joyce's Ulysses. In her daydream, Molly begins by being impatient and then angry at having to wait for her husband. Having nothing to do and unable to fall asleep, she looks around her apartment. And looking around, she notices the clock, the wallpaper, and other objects immediately at hand. Each of these objects serves as a starting point for a chain of thoughts. Ultimately, her images all melt together until finally Molly gets back to the days of her courtship with Leopold. What little evidence there is on the amount of daydreaming shows it to be remarkably widespread. Singer found that 96% of the people who responded to a questionnaire reported that they engaged in some sort of daydreaming every day. Most people did not report that they engaged in wish-fulfilling or escape daydreams. Rather, the most frequently reported daydreams concern future plans and events. To find out at what ages people daydream most often, Singer asked respondents to report how often they remember daydreaming at various ages. Generally speaking, daydreaming reached its greatest peak between 18 and 27 years, with decreases reported up to age 50. Because no elderly people were included in the study, it is unknown if such decreases would continue. It seems more likely that they would not, for it is reasonable to assume that older people might show a reemergence of daytime reverie, especially of a reminiscing sort. The fact that daydreaming hits one peak during late adolescence suggests that such activity can have both an escape from reality and a problem-solving aspect. In its defensive, or escape from reality role, daydreaming provides an antidote to present frustrations. In its problem-solving role, however, daydreaming allows a person to try out different modes of approach to a problem situation. Even if the daydream does not solve the problem, it can at least help people see which solutions might work and which would not. The main idea in this passage is to answer main idea questions, we need to pick an option that describes the passage as a whole. Let's rule out certain options. Option A can be marked out because the author really is not criticizing the escape from reality quality of daydreaming. We can mark out option C. The author is only analyzing the nature of adolescent daydreaming toward the end of the passage and not throughout it. We can also mark out option D. The author only notes the lack of daydreaming in elderly people early on in the passage. Option B is our best choice. The main idea in this passage is to describe the frequency and purpose of daydreaming. Answer B. Molly's daydream begins by her. This is a detail question. Let's find the appropriate sentence that describes Molly's daydream. In her daydream, Molly begins by being impatient and then angry at having to wait for her husband. Looking at the options, Molly's daydream begins by her waiting for her husband. Answer F. Singer suggests that most people report that daydreams concern Let's find the appropriate sentence. Most people did not report that they engaged in wish-fulfilling or escape daydreams. Rather, the most frequently reported daydreams concern future plans and events. Let's look at the options. Obviously, options A and B are out. Option D is not mentioned in this sentence. Option C is the direct choice, planning future events. Let's go with answer C. The passage suggests that adolescent daydreams have which of the following aspects? Escape from reality, problem solving, reminiscing about past events. Let's look at this sentence. The fact that daydreaming hits one peak during late adolescence suggests that such activity can have both an escape from reality and a problem-solving aspect. Looking at the options, option 1, escape from reality, is in this sentence. Option 2, problem-solving, is also in this sentence. How about this 3, reminiscing about past events? That's not in this sentence, but is it someplace else about adolescence? If we look at the passage, we can see that reminiscing about past events does not refer to adolescence according to the author. It refers only to elderly people. So we can mark this one out. Let's go with option H, 1 and 2 only. Singer's research on daydreaming was based on which of the following techniques? Let's find the sentence that mentions Singer's research. Singer found that 96% of the people who responded to a questionnaire. Here's our evidence. Let's look back at the options. Singer's research was based on option B here, having people fill out questionnaires, not analyzing daydreams or interviewing adolescents or observing elderly people. Let's go with answer B. Singer's research implies that the frequency of daydreaming before age 18 is This is an inference question. Let's look at the sentence, generally speaking, daydreaming reached its greatest peak between 18 and 27 years. This implies that there's a lower frequency before age 18 and above age 27. Let's look at the options. Well, before age 18, we can rule out F, it's not non-existent, and we can rule out H, it's not at the same levels. I'd also rule out option J. This leaves us with G, that the frequency was less than between the ages of 18 and 27. Let's go with answer G. The passage implies that human events studied in the psychology laboratory. This is also an inference question. Let's look at this sentence. The associative stream studied in the psychology laboratory comes nowhere near the complexity of the associative stream each of us experiences in our private lives. So this sentence is indicating the associative stream is more complex in our private lives, from which we can infer that its study in the psychology laboratory is not that complex. Let's look at the options. Option D matches what we just did, that human events studied in the psychology laboratory are not as complex as those encountered in private life. Answer D. Singer's evidence indicates that daydreaming. Let's look at this sentence. Singer found that 96% of the people who responded to a questionnaire reported that they engaged in some sort of daydreaming every day. From this, I believe it's reasonable to infer that most people are daydreaming daily. Let's look at the options. Option F is our best choice, that daydreaming occurs to some extent daily. The sentence we just looked at rules out options G, H, and J. Let's go with answer F. The passage implies that the study of daydreaming by psychologists This is another inference question. Looking at the options, we really don't have any evidence for option A that began with James Joyce. We know the second sentence rules out option B. This sentence tells us that the study of daydreaming occurs outside the laboratory. We also can rule out option D. We know that daydreaming focuses more than just on adolescence. This sentence gives us option C. What little evidence there is on the amount of daydreaming shows it to be remarkably widespread. Keywords here, little evidence. I would go with option C. Is limited to a few research studies. The authors claim that daydreaming reemerges in elderly people is based on In this question, we have to be careful to separate the author's claim from the results of Singer's research. Let's look at these two sentences. Because no elderly people were included in this study, it is unknown whether such decreases would continue. It seems more likely that they would not, for it is reasonable to assume that older people might show a reemergence of daytime revelry, especially of a reminiscing sort. Let's look at the options. It seems that the author's claim is based on option J, an assumption, which we get from the previous sentence. The author's claim is not based on an empirical finding, extending Singer's evidence, nor a new research study. Let's go with option J. Energy ascending from inside the sun heats the photosphere, the bright surface layer of gas that radiates the visible light of the sun. The photosphere's temperature can be found quickly from Wien's law. In the solar spectrum, the maximum solar radiation is yellow with a wavelength of 510 nanometers. Application of Wien's law shows that the temperature of the photosphere is about 5,700 degrees Kelvin. If the sun is a giant ball of gas, why does it appear to have a sharply defined surface? The answer involves the opacity of the gas, its ability to obscure light passing through it. Air, for example, has low opacity. Gas in the photosphere has many negative hydrogen ions, hydrogen atoms with an extra electron designated H negative, which obstruct light and cause high opacity. They produce an opaque layer beyond which we cannot see. Only a few hundred kilometers above this layer, at the top of the photosphere, there are a few H negative ions and the gas is clear. Most of the sun's light comes from a layer about 400 kilometers thick, giving the appearance of a sharply defined surface. There's also hydrogen in the solar atmosphere above the photosphere, but no abrupt change in the gas density. A solid probe, if it could survive the 5,700 degrees Kelvin temperature, could drop directly through the photospheric surface and plunge into the sun, like an airplane passing through the surface of a cloud. The convective motions that bring mass and energy from the interior disturb the photospheric surface. A photograph of the sun would show pronounced granules in the photosphere. Each bright granule is a convection cell 1,000 to 2,000 kilometers across, rising from the sub-photospheric layers. Each granule rises at a speed of 2 to 3 kilometers a second and lasts for a few minutes. Slightly darker regions between granules mark areas where cooled gas descends again into the sun. Surging wave motions have also been observed in the gas, with wavelengths of about 5,000 kilometers and periods of about 5 minutes. Such sizes may seem abstract, but keep in mind that many moving masses being churned on the surface of the sun are as large as the entire Earth. Wien's law indicates that the temperature of the photosphere is approximately. This is a specific detail question. Let's find the appropriate sentence where the answer is contained. Application of Wien's law shows that the temperature of the photosphere is about 5,700 degrees Kelvin. Let's look back at our options, and there we see the answer. Answer C. The high opacity of parts of the photosphere is caused by. Let's look at this sentence. Gas in this photosphere has many negative hydrogen ions, which obstruct light and cause high opacity. So the negative hydrogen ions are causing the high opacity. Let's look at the options, and we can see answer G. The depth of the photosphere, which produces the sun's visible light, is approximately. Once again, let's search out the appropriate sentence. Most of the sun's light comes from a layer about 400 kilometers thick, giving the appearance of a sharply defined surface. Looking at the options, the depth of the photosphere is 400 kilometers. Answer B. The ratio of the size of the surging wave motions to granules could be. This is a difficult question. We have to look for evidence in two places. First, surging wave motions have wavelengths of 5,000 kilometers. Next, bright granules are 1,000 to 2,000 kilometers across. So the ratio of wave motions to granules is either 5,000 to 1,000, or 5 to 1, or 5,000 to 2,000, 5 to 2. Either one is possible as a ratio. Let's look back at the question. The ratio could be, look at the options. Option H is our only choice, 5 to 2. Let's answer H. The photospheric surface and air share which of the following features? similar temperature, low opacity, similar depth. We have no evidence for one similar temperature. The passage indicates the temperature of the photosphere at 5,700 degrees Kelvin, but mentions nothing about the temperature of air. We also have no evidence for three similar depth. The passage indicates the depth of the photosphere at 400 kilometers, but nothing about the depth of air. How about two, low opacity? Let's look at these sentences. Air, for example, has low opacity. And then, only a few hundred kilometers above this layer, at the top of the photosphere, there are a few H-negative ions and the gas is clear. From these two sentences, we can infer that air and the photospheric surface have low opacity. Let's go with answer B. The passage implies that as granules rise through the photosphere, Let's look at these sentences. We see that bright granules rise, they have a certain speed, lasts for a few minutes, and then this next sentence, slightly darker regions between granules mark areas where cooled gas descends again into the sun. From this, we can infer that the granules cool as they rise. Let's go with option F here. Maximum solar radiation is. Let's find the appropriate sentence to answer this detail question. In the solar spectrum, the maximum solar radiation is yellow. Let's look at the options, and answer B says yellow. Let's go with answer B. The main idea of the second paragraph is to This is a main idea question, but it's only asking us the main idea of the second paragraph. Let's look at the second paragraph and see how it begins. If the sun is a giant ball of gas, why does it appear to have a sharply defined surface? This seems to be the main idea to this paragraph, trying to answer that question. Let's look back at the options. I'd rule out F and G. Those are too specific and are only part of the second paragraph. Option H is not in the second paragraph at all. It occurs later. So let's go with option J. The main idea is to explain why the sun appears to have a sharply defined surface. Answer J. Granules and surging wave motions are similar in which of the following characteristics? Origin in the subphotosphere, speed, duration. Let's look at these one at a time. First, the origin. Well, we have evidence that granules originate in the subphotosphere, but not surging wave motions. It only indicates that surging wave motions are observed in the gas, which I assume to be the photosphere, not the subphotosphere. Let's mark out one. How about two, speed? Well, granules rise at 2 to 3 kilometers a second. We have that evidence, but we have no evidence on the speed of surging wave motions. Let's mark out 2. How about 3, duration? Well, granules last for a few minutes. Surging wave motions have periods of about 5 minutes. It's reasonable to infer that the durations are similar. Let's go with answer B, 3 only. If a particular bright granule lasted 10 minutes, the passage implies that it would cover a distance of. From the passage, we see that the speed of granules are approximately 2 to 3 kilometers a second. Let's take 2 kilometers a second. This implies that a granule would cover 120 kilometers in a minute, or 60 seconds. This also means that a granule would cover 1,200 kilometers in 10 minutes. Let's go back at the question. Let's go with answer H, 1,200 to 1,800 kilometers.